Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, Nick.
Hey, I'm John.
Hello, man.
And, we got John back, he's done, doing what he's got to do. But, and we're all here again. And the big thing that we want to do is we want to jump in on the preventative maintenance side of the house again. So we want to get back into that series. It's going to be a series. So I know some people are gritting and bearing. Some people who work in maintenance, you're talking about PMs, and people probably don't know what to talk about. But
try to sound like it.
yeah, right. At least we'll give you the feeling that we know what we're doing. So last time we kind of talked about what is PM and what is PM in additive manufacturing. So this week we kind of want to get into the PMing of the mechanical side of the house on 3D printers, because 95% of your printer is mechanical. When you think about it,
most of it is. I mean,
right.
It's very, very limited electronics there.
Even resin printers are still about 40 to 50% freaking or more mechanical.
Yeah, you take a little bit of the motors out, but it's still. I mean, a lot of it's that process of that linear actuator.
Especially if you're dealing with, and you start dealing with like we looked at earlier, the Fosen 8K, the large format printer.
Oh, that thing's massive.
Awesome. $3,000 though, but
massive.
It is massive. But the thing is, it's mechanical. It's got mechanical door hinges on it. It's got the mechanical what is it? Freaking ball joint. I think it was running linear rail.
No, it's running linear rail, and then I think magnetic. The magnetic bed. I'm not sure if it has
It doesn't have a magnetic bed on it at all. It's all solid mount.
No, the VAT.
Oh yeah.
But to be honest with you, it's not something that I've used before. But we got a quick peek in at Rapid, and it does look like it's a pretty large machine no matter what.
It is darn cool.
But it does look like it's got a lot of capability of what some people were looking for in large format resin printers. It's not as big as, of course, a Voron 2.4 bed or like a Prusa XL, but for 8K resolution,
and for the price it's at ain't bad. But the thing is we kind of jumped off there for a second, but it's something that we like. All those require mechanical PMs. Everything we build requires a mechanical or structural PM. Because if you think about it, everything has got some sort of hardware connection to it. So, with that, I'm going to turn it over to you guys. When we start talking about mechanical and structural PMs, depending on its application, we're talking about additive manufacturing, we could talk about robotics if we really want to get into that. What are you thinking?
You really could take that in a lot of different directions. If we're talking about IT devices, I know we're most of the time focusing on a lot of industrial things, but we kind of stand in the middle of a lot of IT and OT things. People think everything technology is IT, not necessarily, but majority of that stuff, it works off of IT systems, so you end up having to get into those PMs. And on the IT side, if that was what I was viewing, I think about database maintenance as a PM. Yeah. You clean your data or you clean your queries or things like that. But that also can kind of go back onto the mechanical side, the actual mechanical side, because that database is maybe it's reading robot codes, and if you're not performing maintenance on that database, then your mechanical side's not going to work. Mm-hmm. So you grease those joints, all those gears, things like that. I would count that still as preventative maintenance that is vital to that machine's everyday wear and tear. But I also view IT as well in there. If you've got sensors, if it works off the database, those things still need to be considered. But mechanically, I'm thinking wear joints and things like that. I guess I don't have as much of the mechanical or the maintenance side.
From the IT side, wouldn't we, because here's the thing, if you think about it, especially if we talk about the databasing and stuff like that, we got to make sure the actual server it sits on is clean. We got to make sure
really.
that server has got connection. It doesn't have any frayed connections on it. You got good network drives on board. So you're more your mechanical on and the IT side is more or less like your server maintenance of the thing.
Yeah, and
Which is the same thing.
Some people don't view that.
Especially if you got spinning disks versus not.
I mean, there's a reason you call it infrastructure. Like it's what you build, and it kind of gets off of a little bit of what we were talking about. But like if you keep your mind open, it goes with, you're building your architecture for your software, your facility, whatever, your industry, your production floor. And if you're not careful about your infrastructure, your drops, your fiber, your PLCs, like caring about the ports in the area around them is just as important as caring about the machines that
right.
use them. So, I mean, honestly, though, if you're asking me mechanically what I go to, wear points, like what is that joint that moves 20,000 times a day, that I go to preventive maintenance for things like that. But then I'm thinking about high usage.
Mm-hmm.
Those are my higher risk, so I assess risk based on how much something's used. And then the other part is if you've got a backup, then I do preventive. If everything has a backup, I just do preventive maintenance on everything. Yes. You just put the backup in place and do the maintenance, and everything's on a schedule. Yeah. So I think about it as if you need to change out that tool head, that socket, because you've used it so many times, we'll swap it out now. You need to calibrate that tool. We'll swap it out now. I'll calibrate it. You're already moving. We don't stop. So
makes sense.
At least on a downtime.
So I'll just touch for a second on databases. So from a database point of view, in today's environment, the database could be cloud-based or it could be physical. Yeah. If it is either or, it's just a matter of which flavor that your company or organization has chosen. The biggest thing to think about with a server and a database is most of the databases, if we're just talking pure data, should be solid state. Mm-hmm. Solid state has so many writes and reads that it can have. So with that, you offset those write and reads with maybe a RAID system. Or you offset those write and reads with maybe multiple systems and some cloud backup. The other thing you have to consider is the fans that cool the servers. These are things, even though they're designed to work with those type of systems, over so many hours those things can fail. You also have to look at spikes that you have from electrical surges and things that can happen that could actually compromise some of the things in a server. These are things that I would think would be physical, because if you have a surge, it could burn up a motor. If a motor burns up, I don't cool several drives that are being backed up, and then I can lose data.
Right.
From that point of view. So now I'll move on. So for me, when I think preventive maintenance from a mechanical point of view, what I want to think about is your regular cleaning. Yeah. So from each print that you do on a 3D printer, there are some simple things that you do. You might want to use some compressed air and blow off the bed and blow off maybe, your drive systems. Maybe you want to make sure the nozzle is clean. Maybe you want to make sure you wipe down the bed before the next, in between prints, after so many prints. Not every print, but maybe so many prints. I want to verify that the adhesion of the bed is correct.
Yeah, makes sense.
So those are some of the things I would think about. So general maintenance is the first thing I would think about, is the first line of defense for 3D printing.
I think that general maintenance is one of those things of where you really can't go wrong. No matter how you look at it, because general maintenance can take a standard point of do I replace a bed during that point? Is there an issue with the bed that's causing warpage or something like that? Do I need to replace? But it's greasing on your rails. It's greasing your ball screws. It's getting the dust off of your wheel bearings if you're using wheel bearings. If you're using like the underset of the house, and you're still using the plastic wheels and stuff like that on the rubber wheels. Clean those things off a little bit. Hit them with some compressed air, like Ed said. Get those things moving. Your bigger printers are probably going to have some grease joints and stuff like that you got to hit. And be on their own, scheduled PM process for, digital, for regular cleaning.
Hopefully some type of ventilation, maybe. If you have some resin or some hazardous chemicals, you should definitely check your filters.
Yeah, filter replacements.
Yeah.
I think every time you do a PM, especially if you've been running that printer for, say, 20, 30 hours
Straight.
Or even if you're running it over 2 weeks combined time, I think it might be time to, if that filter is starting to look a little, replace the darn thing. The thing is printers are cheap. Your health is expensive. Anybody who's dealt with freaking, medical bills knows for a fact that that's the case. The thing is printers can hurt you. They can hurt you very, very hard. However, is making sure that if they're mechanically sound, the likelihood of them hurting you is very slim to none.
So two things to consider about when we start talking about filters in particular. Filters are basically just on, how much particulate they allow through. Mm-hmm. But you can also check that with CFM. So you can either add sensors or you can take some type of meter that reads CFM and you can verify the CFM that's going through the filter. The reason I say this is that if you have a print farm, you're on a particular budget, and that budget, maybe doesn't allow to change filters, or maybe there's a lot of time involved in cutting those filters. Mm-hmm. If you decide to buy the filter material yourself. So one of the things I would say in particular, Nick touched on it in particular, with lubrication. So lubrication is not necessarily based on look, it's based on the amount of hours of use.
Right.
And your 3D printer manufacturer has a suggestion for each of the parts if you have a verified product from some manufacturer. If you built it yourself, then you're going to have to do some research yourself and verify what is the routine for a particular bearing, linear rails, belts, and so forth.
It's also the type of the lubricant that you're using.
And be careful with that, because some lubricants can attack plastic.
Yeah, true.
Or rubber.
Or metal.
Yeah, so be careful with it. Or it could affect adhesion on your bed.
Right.
So be very careful with how you do lubrication. And
the thing is a lot of time, and I'm glad we're starting to get into this lubrication thing, because most lubricants, you can go from a for example, it's like the spray on WD-40 stuff. It goes on as, I guess you'd say, gas or thereof, propelled liquid.
Somewhat solid.
Propelled liquid, I guess you could say, and it goes on as as a solid pretty much when it hits. It coagulates and solids up. However, and Champ is over here gritting at the teeth, and his physics brain is going freaking 3,000 miles a minute.
No.
You put that stuff in the enclosure, it gets hot, it turns into a gas can.
Oh yeah. Yeah, don't put it under vacuum either. If it's hot and under vacuum, it's gonna go boom.
But the thing is it starts to deteriorate your prints too.
Yeah. So one of the things I would consider, like most bearings will not be requiring WD-40. WD-40 is meant for mechanical, a truly mechanical.
Well, when I say WD-40, I mean white grease, the lithium grease.
Well, lithium grease is different, or moly is different. But if you check with your manufacturer, they're going to tell you what to use. Although I'm not saying that you cannot use WD-40, I wouldn't recommend against it. But normally WD-40 is meant for almost like when I'm breaking fasteners, or if I have a hinge. It is meant for a pivot and an incline going together.
Makes sense.
It's not really meant for a bearing. But I understand what you're saying, because someone that has a print form that does not have this background would lean towards WD-40.
Or white.
And that was a very good point to bring up.
See, I like using, especially on printers that are out facing, that aren't enclosed and stuff like that. I like white lithium grease, to be honest with you. It's easily readable. I can easily find it. I can spray it onto slick surfaces, like guides and stuff like that. It's fine, no issue.
Yeah.
However, if it's on an enclosed application, I really don't like to use it. Even though I don't know, you're the physics guy, so I'd default to you if it involves anything that deals with mathematics. Is the fact that I don't know if white lithium grease on linear rail has the right heat transfer that will create the phase transition from solid to gas.
Yeah, I think it's. I mean, I'd have to look at a lot of like the chemical,
chemical breakup,
like how it reacts with certain things. But honestly, at a certain level, I mean, heat and chemicals that I mean, if you have some chemicals that came into contact with each other and you're experiencing heat, that is a chemical reaction.
Right.
Heat dissipate. That's not good if you're just sitting around. And sometimes those chemicals can be kind of very toxic, which is why we say be careful. But at the end of the day, like for me, the preventive maintenance of those things is even just the safety and what happens. What happens if this PM fails too?
Right.
I think that assessment is also just as important. I mean, some resins, I mean, they're proprietary blends. People are just trying their own plastic polymer blends. So, like, you can get some incidental reactions, but I think in an enclosed environment, it's safer. But I wouldn't want to be in there.
Yeah.
So, but if we're talking about lubrication and lithium grease on those on like linear rail ball joints, or you're talking about just standard. Your like, let's say your Z lead screw that's on majority of like consumer printers. I mean, you have some type of Z on all industrial ones, but if you just want to grease that, I mean, I suggest the white lithium. I haven't had, unless you're printing at temperatures of upwards of like close to 300 Celsius, I haven't had the need to print that high. At those temperatures, I would then I worry about the phase transition. I worry about when it becomes from that liquid to a gas. Yes, you should be thinking about those things, because then you're inhaling that gas, and I can tell you that's not good for your lungs. But yeah, it's also, when we talk about preventive maintenance, lubrication is vital. But also, if you have like a dual Z, or if you've got several Z motors, alignment is just as important as lubrication, because you could be lubricated and it'll still grind, and because if your plate is not aligned, it'll still not pull. If your steps are not in the same sync, then they'll step at different lengths, and you'll rip that bed apart.
It'll beat it to piss.
That's basically the third step is calibration.
Yeah.
Which assesses alignment. And just to follow up on what John was saying, as far as lithium grease, you would have to be about 200 degrees Celsius, really 215, and probably 392 degrees Fahrenheit before you can melt lithium-based.
You can go
grease.
from a solid to a liquid
So
to a gas.
there's, as far as my understanding,
that's close enough.
I don't know of a system that even enclosed, where the extruder gets enough with the volume.
Rails will get that hot. Yeah.
You know what I'm saying? Like,
well, I think
you would have to move at an RPM or a rate of so fast to create that type of friction. You would never be able to break lithium grease down moving that fast.
I think,
and the extruder could never reach that temperature to heat up the volume of air, even enclosed.
Yeah.
To get to that temperature.
That's a good point. We're thinking about the hot end temperature.
Right.
We're definitely thinking about the heating block instead of the entire enclosure. It makes a lot of sense.
Insane.
Yeah, I think that. I mean, that's why we have a heat brake. That's why you've got special heat brakes as well.
The exception is all bets are off with ABS.
Yeah, you get higher temperatures. I mean,
polycarbonate, ABS depends on how long
fiber.
you're printing and where that volume of metal is.
Yeah.
It could, if it's close enough to the rails, cause that.
I can tell you, like, for example, my Voron, and I've used white lithium on my linear rails, just to add a little bit of precautionary measure to them, right? My Voron will run chamber temperatures of 110 degrees Celsius. That's chamber temperature at the top of the chamber. If you're talking about where the linear rail is, say where my tap is located, I have a sensor that's on board my. And this is going to get way off topic real quick. On board my my MCU that is on my print head that runs my CAN bus. That does not exceed above 95 degrees Celsius.
Yeah.
Yeah.
So like
Or
I said,
centigrade.
I don't think it's gonna get. Yeah, I don't think it would get
it's
to
not
that
gonna
point.
happen. Yeah.
I mean, you'd have to move so fast, coupled with being like printing for 50 hours,
Right.
right? Like, of course, if you have an enclosed space that is truly in vacuum, then
That's a different story.
you have but so long before that heats up.
Mm.
Right.
So yeah, that's a different story. But if you're able to put that in a vacuum, we got other questions.
There is one more.
We kind of want to try
component.
that. So
Yeah.
if you want to see it, let's
Then we
try
probably
something.
want to move on to the next layer of
Careful.
that, preventive
Big
maintenance.
bang.
It depends also on the heat of your bed.
Yeah.
Maybe you're more aggressive with your heat on your bed in conjunction with that chunk of metal that you're using for your extruder. Maybe those things, if I stay those things in the same area, highly unlikely. Highly unlikely that would happen. But maybe that's something to consider if you're going to raise your temperature of your bed. But the next thing
Laundry, yeah.
I would say is filament handling. Moisture.
That's true.
Moisture with your filament, whether you realize it or not, will bite you in the end.
Yep.
So you have to pay very special attention
Right.
to the filaments you use and how you store them.
Well, yeah,
Any
it's
film
yeah,
that
the
can take in
storage.
water.
Yeah. Well, they it's almost as if
Yeah.
they are looking for it.
Right.
There's a scientific word for it. I can't something scopic, hydroscopic.
Hydroscopic. Yeah,
Something I was it? I didn't do well in English. But that's one of the things that is a characteristic of the filament. It's if there's moisture in the air, it'll absorb that, kind of like how we are a conductor, or metal is a conductor for electricity. It exists in such a dry state that it's looking for some of that moisture, and it's only natural.
Hydroscopic.
It is hydroscopic. Yeah, so there we go. But that's the thing, and this is why we have dry boxes.
Mhm.
This is why you have clean rooms as well.
Yeah.
And to be honest with you, if you were smart, you would have your enclosure kind of with your. This is why a lot of the printers want the filament in the enclosure with it. It's also drying it as you print. So
I thought about doing that with my Voron, is building an extension on the top of it
Yeah.
and put my filament in there, just to go with that. However, I will say this, y'all, please don't put your filament in the damn oven.
people do it. Don't do it.
Oh yeah, don't do it. Don't be stupid.
Well, don't
However,
unless you understand.
yeah, melting point.
It's a different way to do it. Do you have a garage? Store your filament in the garage.
Yeah,
But-
there's human in there.
Yeah, but
No,
the thing is what I do.
In the summertime, it's dry enough
Yeah.
that would keep it at a certain temperature, and you do not have the humidity. The humidity is a lot lower because the heat index is higher. If the heat index is higher, then the humidity is lower.
See,
That's
what
fair.
I do, I guess you can say kind of just spoiled with what I got, is I take my filament when I open it up, when I get ready to use it, I'll throw it in my Voron with a couple, of the Z-test cubes, hold it up off the build plate, crank up the build plate to, at least a decent temperature that won't melt the filament that's on it, and let it sit. And I use my Voron as a dry box to dry it out before I even...
Yeah, I mean, the whole idea behind it is like, I mean, the reason Nick says don't use your oven is because
It's a safe
it's a safe. Most people don't understand. Your oven is in Fahrenheit. All right.
Yeah.
When we are dealing with a lot of these
Unless
things,
you're overseas. We get some of the overseas listeners, you still be in Celsius.
You might be in Celsius if you're overseas. Yeah, that's fair. That's fair. Most in America, most are Fahrenheit. So whenever people are like, I need to put it at what temperature for it to be dried, and they say like, it needs to be at 200 blah blah blah, or it needs to be like at 150 Celsius. They put it at 150 Fahrenheit, and you got melted, like half melted, not fully melted because it's not at its transition point, but enough heat to that will melt it.
Turn into goo.
And or if you don't even get there, it makes it brittle. You could ruin your print. Like Jason, my brother, has T-glaze, and he did the same thing. And the chemicals inside sometimes react as well with how that heating element heats.
Makes sense,
right? And if and think about it, your oven is not the cleanest unless you get in there and clean it every time. It's not the cleanest, so you have to keep that in another sort of container. You put in that container. That's where you cook your food. Stop doing that. So if you're smart, get a dry box or a dehydrator, and you can 3D print. Well, if you don't have that yet, you can put a dehydrator in a smaller enclosure, and if you don't put the lid on, it's just going to take longer, but it will heat that enclosure. I mean, honestly, I've put several full rolls in a standard, not even a large food dehydrator. I just stacked up and printed the side walls higher so it would hold the heat.
Now I'll say this: if you get reputable filament and it's enclosed, it's locked in and stuff like that, it's vacuum sealed pretty well, you won't have that problem.
Out of the box, you shouldn't see that issue.
No.
But this goes with preventative maintenance. You check your consumables. You're checking your nozzle. Do I have
the
any?
big one. The nozzle is the huge part.
Do I have any wear and tear? Like if you're printing carbon fiber or any type of wood filament, anything with any type of flex of another type of filament. If you have there's some PLA pluses that just has bits of PETG mixed in, right? If you have that, the way that there's a chemical issue and a heating issue there because the melting rate of the PLA and the melting rate of the PETG are going to be so offset that you might be melting your PLA, but the PETG is still solid. So some people might think of that as, my print's going to be sturdier because it's got things mixed together. But no, what ends up happening is it clogs. Yeah. Or you heat it too hot and you're burning your PLA and you're getting elephant foot. You're ruining your print. There's a sweet spot. However, if you find that sweet spot with something it becomes abrasive. And that abrasiveness is what tears up your
and do your math. If you're gonna run an abrasive filament and you know what nozzles you're running, if you're not running a diamond tip nozzle or you're not using the iridium nozzles and stuff like that, or the new nozzles that we see from Slice Engineering,
was it Galvium or
Galvium or whatnot? Which I'm gonna get my hands on one of those and we're gonna test that damn thing.
Oh, I have one.
But so we'll let Champ test it.
I have it.
So the thing is if you have this filament, you're going to be running a lot of it. If it doesn't cost you a lot to buy a roll of filament, for example, if you're not buying from some of these bigger manufacturers, run a roll through it and see how fast it deteriorates your nozzle. Do a couple XY prints, the cubes, do 10, 15, 20 and see if you start getting a deviation and stuff like that.
Everybody do for another benchy.
So, right. Or exactly. Always do a bench, and that's the thing.
That's part of your calibration.
Is whenever you do a calibration, you change your filament, you change your nozzle, run a quick benchy or run a quick bed level real quick with it, or an XY cube, and make sure that you're on point. And also do temperature towers. Temperature towers should also be part of your PMs. Even though you're using the same filament over and over and over again from the same manufacturer, could be from a different batch. Do a temperature tower to make sure that you're not having hot end issues.
Yeah. So to go back to just to follow up on what Nick was saying, so the batches that you get the filament from could be different, and that's normally given if you do a little digging. So that's back on what we call filament maintenance. When we're talking nozzle maintenance, I'll give you an analogy. Can wood eat metal? Yes, it can.
Eventually.
No. Pressure treated wood,
if
you use regular nails, will eat the nails. It's a chemical reaction between a regular nail and the pressure treated wood. However, you use galvanized nail, you don't have that problem. So be aware of the materials in the nozzles. But sometimes the materials in the nozzles can react to each other. So it's kind of not, it's a science, but it's also a craft. So even a welder, when he's using different materials to weld, he knows to use certain types of welding wire with certain types of material. Stainless requires one thing, standard metal requires something else. So I mean, you have to keep those in mind when you're doing these prints. If you're going to use some exotic type of filament, then you need to do a little research and verify, hey, what are the consequences of using this? Now, Nick said that you can use some special material nozzles, and that's fine. But if you're on a budget, you can also use standard nozzles, brass nozzles. But you have to be aware of how much wear happens from how much filament I run through the nozzle. So you have to do a little mathematics and verify and consider if that's cost effective for a low budget setup.
And the thing is you know, some people have the luxury of living by the coast or working by the coast. Like the guys working on oil rigs, for example. I don't know how many people we got listening to us. I know I got some people down there in Texas. You know, if y'all working on the oil rigs, you know, out there on the Gulf Coast and stuff like that, you know, out there by Texas A&M, Galveston area, whatnot, you know, and even overseas, the closer you are to the water, you're going to start dealing with electrolysis. You're going to start dealing with saltwater electrolysis, and which saltwater electrolysis will eat the heck out of freaking anything stainless steel. It will eat that like nobody's business tomorrow. So, you know, and also eat, you know, brass. So if you're in a saltwater environment, even if you know, your equipment's not getting wet, we know that. However, if you have salt water in the air, or if there's a chance that somebody may have salt water in their hands or something like that, you're dealing with a saltwater electricity. Saltwater and electricity don't mix. They start causing electrolysis and starts eating things. So, you know, make sure that you're checking that for any type of corrosion if you're in that environment. Is, you know, we take it for granted in areas that we're not near, you know, saltwater, you know, ingress areas or and stuff like that. But if you are in one of those areas, check for corrosion. Corrosion is another thing that can positively just absolutely ruin your day from Jump Street.
And just to follow up on that, Nick, so normally what we do in environments that are corrosive, we add a sacrificial metal. So maybe you, in that environment, you add some type of softer metal, so you can see the deterioration of that metal is happening at a rapid amount, and you can say, hey, when this gets to this point, then I know that my nozzle is not, the integrity of the nozzle has been compromised. So you can do some things like that because it's hard in those type of environments. Or an environment where you have a lot of debris, sand, or
right.
Yeah. So I mean, so you have to kind of, you know, in those environments you got to do some special things. You know, maybe
and it's like we saw an article the other day. Defense Weekly did it on in a couple of the forums that I watch, stuff like that. We have 3D printers on board Ospreys with the United States Marine Corps, using with Nywick Pack. Coming up with these ideas and stuff like that to print the casts for service members that are hurt in the battlefield, or that they had to go rescue some of that from a training area or whatnot. They can print their casts pretty quickly and get them moving.
Stabilize it.
Right, stabilization stuff. So with that, you're dealing with vibration. You're dealing with different parts of corrosion that you might not see before. You're making sure that, vibrate. The big thing is the vibration standpoint. Because vibration, you're dealing with things that can rack things loose. Tighten down those bolts. Make sure you don't have anything in there with it. Sand, dirt, debris, bodily fluids. Blood or contaminants. Don't make sure that's not in there with it. Hate to bring that up, but the natter the beast that they're dealing with. Is check everything, make sure you're not dealing with any, cross-contamination type of stuff.
Yeah, cross-contamination is huge. Yeah, I mean, honestly, if you're cross-contaminating anything, like, you're causing problems for somebody who maybe their system didn't realize touched any of your chemicals, and now they're not doing safety checks on any of that. And
right.
You've caused who knows how much pain. So it's very very dangerous if you cross contaminate, and it's mostly in food, but it can happen in any chemical situation. So
Well, I would say firmware and software updates is probably another key factor for two reasons. We discussed the security issues with having a open network. Or we've also discussed the implications of not updating firmware because maybe there's some exploit that just came a 0-day exploit that was just discovered. With firmware updates, I think, and software updates that help. But also you get added features with firmware update. So maybe it deals with some of the things. And just to touch on what Champ said with contamination. Contamination is not just, having some debris but it can be the oils in your fingers touching the bed. I mean, one of the things that I suggest, is probably a newbie thing, is take you some 99% isopropyl alcohol and wipe your bed down before each print. I mean, it doesn't hurt. It also makes sure you have a good foundation to start with. So that would be something else I would suggest.
I think that's a given these days, and I couldn't tell you the amount of bottles of isopropyl alcohol you see on the floor at Rapid. I think every single booth has got probably we had 3 or 4 of them bottles sitting there.
not happy with how much I've used.
Yeah, I use more than I probably
The
should.
resin prints all have to be washed in it.
But I think if
Consumables.
I think
it's
even
consumable.
with people that do sculptures, they do some type of process where they clean off before they start the next cut. So I think it's not a bad idea. I mean, it's the nature of the beast. I think a guy that loves a car, he goes out there and washes it and waxes it, several times a week. So you should think of that investment you made into that print form or that investment you made into your hobbyist 3D printer as something that you want to make sure that the bed is probably that's ground zero. And you want to make sure ground zero is good.
We just kind of talked about laid into a little bit of the consumable side of the house. We talked about the filament. We've talked about the nozzles. However, the thing is, you start really thinking about your consumables being your IPA bottles. Make sure those are full. Make sure you have clean cloths available that are cotton to be able to wipe down the beds.
Lint-free
cotton to make sure you can wipe down the beds. Stuff like that. Stuff that won't induce problems.
Microfibers.
Yeah, microfibers are another one. Harbor Freight, great place to go buy microfiber cloths. You can buy a bunch of them for 20 cents. So great investment. You don't have a Harbor Freight? Ask somebody for one.
You'll find some microfiber anywhere you can get towels.
Amazon.
You'll find something. Yeah.
Or you get the lint-free ones you can buy in the box.
Yeah.
So the thing is, it's your consumable and do consumable research. Make sure you know how fast these things are going. Make sure you're tracking it. Make sure you have a spreadsheet of some sort that says, okay, cool, I'm eating through this rate of consumable by this. A rag for a printer can last months, without any issue to it, as long as it's taken care of.
Yeah, as long as you're not dropping it on the floor, throwing it around.
If you just drop it on the floor, replace it.
Yeah.
However, isopropyl alcohol may only last a month.
Or you can go streamline and buy packages of lint-free wipes.
Yep. And
you can go a wipe area. But I would like to venture into a few more things just to make sure we cover the areas of the preventive maintenance. Like I said, power and electrical connections. This is something that can migrate over time with vibration, with just use. This is something you probably need to check, probably not weekly, but I would say quarterly. You would want to verify those connections because they can't come loose, which could cause problems with your MCU.
It should probably be in your TPM now.
Yes.
Your team member PM should be checking to make sure that your plugs are somewhat decently connected.
Yeah, but I think that I would agree with both of you. I guess there should be the team member checking the basic checks. Does the plug look like it's on fire? No. Okay. Well, that one's fine. Check your area.
Well, that's
and
visual.
then on a higher.
Yeah.
But I'm not saying just visual. I'm just trying to. I was just saying I'm plugged into this wall unit and it's not charging my torque tool battery, whatever.
Right.
So you're like, okay, noted. Move on. But the bigger PM, I would say, would come from the maintenance side, who's checking that fuse box, and they're like, okay, this fuse is blown. Here's this, and we've got extras.
Right.
So I think there's levels to it.
So normally, just to explain TPM, so normally TPM from, let's say from a shop floor environment, TPM and say PM is a little bit different.
Right.
TPM is check this, and then normally it's a visual check.
Okay.
Or normally it's a wipe this or wipe that. That's normally a TPM check. That's a daily or a weekly. Normally when you're talking about like a quarterly PM or a yearly PM, I check every connection on a terminal strip. I take a screwdriver and I make sure that every screw is tightened as I can get it. Because the TPM should give you immediate attention. I need it. Then the PM should be the thing to verify that the TPM covered what you was trying to do. And you both are right. There's no right or wrong in this particular situation.
As long as you're checking something, right?
Right. Well, I'm saying if I do a visual check, a smell check,
same thing as checking your fire extinguisher,
or
right?
hearing check.
Yeah.
If I'm doing all those things, then I should see anything that's abnormal. If it's nothing abnormal, just because I know the nature of vibration and connectors and things, yearly I should verify that those connections are good.
Yeah.
All right. So
Just don't do a taste test, please.
yeah, the next thing would be
It won't last long.
regular usage. If you're not using the printer, expect to have clogs.
Yeah.
I will say it one more time. If you are not using the printer, expect to have clogs. So regular usage is a preventive measure. If you don't use it and it sits, then you leave yourself to some of the things that happen with things sitting.
Yeah.
Right.
Yeah, if it has to circulate any type of fluid, then that fluid, if it's not moving, if it sets, you gotta replace. If it's stuck in the hose, you're replacing the whole hose too, and the fluid.
And that's not easy.
Well, let's hope it didn't explode on you.
And that's not fun.
almost had it happen to us the other day.
Yeah.
And then I would say the last thing, because I know we get a little long, is documentation.
Yep.
Everything we just said needs to be documented to verify so that we have some integrity in the process to say, hey, I did not pistol whip this. I verified those steps.
Yeah, I agree with that.
It's
I
a
think
check.
integrity is important. Yeah, because it's the same thing. So you order when you like rented books from the library when you were in school, you'd have to. I mean, it's probably very different nowadays.
They'd sign the front of the book.
There was a little slip in the front. You'd have to sign out the slip, and you would date and everything. It's the same situation. It's like, okay, I am taking care of this station. I am checking these things, and if you're in a place where safety is paramount, you are now accepting the responsibility of if someone checks this system and it fails and injures them, and it's one of those things that you were supposed to check or change, you are responsible for that injury now. And that's not going to be on my conscience.
I think, especially if you're an operator should check out the machines and say, guess what, I've taken full responsibility of this machine today. This is what I'm dealing with, especially if you're in a large print house type of thing. If you're in an 8-person freaking little, print shop and stuff like that, it might not have that availability. However, it's go by and initial the printers, saying that you looked at them, you verified that nothing's on fire, and stuff like that. I think that would be your caveat. And the one thing is and I'll leave it at this: most printers do not have lotto environments or lockout tagout availability. So be very wary. Don't send a print to a printer that's possibly undergoing maintenance. Understand which ones are going under maintenance that day. They can be unplugged from the wall, but if they're to be doing live maintenance, like a quick maintenance print or something like that they can run to make sure that everything is flowing correctly. Don't send a print to that could possibly injure or harm somebody.
I'd go one further than that when we're talking safety. It should be unplugged from the device and the wall if you're doing any type of maintenance where your hands is close to any electrical voltage.
Right.
That should be.
You should unplug and make sure you discharge any static because.
Fortunately for us today, because of pulse width modularization and
They may be lying.
switch mode power supplies. They build that into those, but that doesn't mean
Okay.
that does not mean a component will not fail.
Yeah.
Trust nothing.
Yeah, I've been shocked by too many capacitors.
Trust nothing.
Yeah.
I will say one more thing. On TPM, no matter how big your print farm is, your commercial farm is, your industrial application is, you should have a TPM trail.
Right.
There at every point where there's supposed to be a check, either on the device or on the floor, there should be a thing with a symbol that say check, check, check visually. I shouldn't have to have a list. I should be able to visually look. The Europeans are normally good with this. They had visual management. We should think about these things when we're starting to get into 3D printing as a entrepreneurship or as a actual full-scale business. Think about adding these visual management tools that anybody new can walk and say, hey, check.
Right.
Sight, hearing, and smelling.
That's why they got the red lights on most of the PLCs for processes, right?
Yeah.
And the
Red,
thing is, you
green,
can add those to
orange.
printers too. So, you can actually see when you're in a fault status.
Yep.
RGB lighting, making sure that you have, a master kill switch. Integrate, if you're building your own printers, integrate an e-stop.
Put an e-stop on it.
And if anything, pop that e-stop before you start doing maintenance. Because the e-stop will disconnect it from its mains power.
And also, I would even go a further step than that. I would put in thermal protection in line with anything that is being heated, where it can generate an enormous amount of current. That if it'll have a thermal fuse, install a thermal fuse so that if the temperature reaches a certain point, before it can reach the point of catching on fire, the thermal fuse is sacrificed, as opposed to sacrificing components on the actual printer. Think about incorporating these type of things.
You would need that. I mean, that makes just
They
that
do
just
them in
makes
hair
sense.
dryers right now.
Fail safes. I mean, your print, like, you can even get down to, like, you don't want it, but there's always fail safes where you can have critical fail print resumption, and I mean, that's in the software. But at the end of the day, you'd rather not have to use that. So,
But if your wife uses a hair blower or hair dryer,
yeah,
it has a thermal fuse in it,
okay.
and also
Okay.
it has GFIC
I know
protection.
you wouldn't know about the hair dryer.
If it's dropped in the water. These are things that happen
that's
because
true.
these things
That's
have happened in the past.
Yeah.
Those things have burned down houses.
Yeah.
Or killed people because it dropped in the shower, in the water, in the tub.
Yeah,
You know,
it's true.
And I think that kind of brings us, I think we've kind of hit the morbid side of the house now. I think that brings us to the end of at least the mechanical side of the house for PMs, or what is PM. So, the thing is we kind of covered more of your mechanical and your overarching. So that's what we're, next week we're looking more or less into your electrical PMs. How do I check a breaker? How do I check a breaker? How do I check a fuse and stuff like that? What do I need to do to make sure this is, actually correct or not correct? But I want to say thank you. I'm looking at the stats right now. We're at 1,755 all-time downloads right now. We keep climbing and climbing and climbing, and we appreciate it. We really do. I know I do. And I want to say thank you, to everybody, that is tuned in. If you see any or hear anything that you'd like a further explanation on, shoot us an email, get in touch with us. We're more than happy to help you. You can get us on all the socials. You might see some funnier things coming soon that we're going to be dealing with. You'll see some more serious stuff that we're going to be dealing with sooner or later. Hopefully that, we can get y'all thinking, having some fun with it. If you're going to be at South Tech this year, up in Greenville, South Carolina, let us know. We'll stop by and see you. Have a little bit of conversation with you. We definitely don't mind it. So, and I know that there's still some stuff that we got to do, that we still do outs from Rapid. So if y'all are listening to us, I just want to, I just want to, thank every single one of you, for that. Yeah, sorry, that was the garage door that just triggered.
my feet started vibrating.
Yeah,
a little bit. I was like, what was that?
I have an auto trigger on the garage that
That's
closes
funny.
at a certain time. So if we owe you a due out, from Rapid, I promise you we're coming to you.
Yeah,
We'll be seeing you, send me emails, getting some interviews set up, stuff like that for people we want to talk to. We highly appreciate every single one of y'all. We wouldn't do this if it wasn't for you. Thank you all, and I'm going to pass it over to you.
Like I said, I kind of mimicked the same thing Nick said. We appreciate all the support. I would like to say we do appreciate all of the downloads we've gotten. We appreciate everybody that's given any suggestions. I would like to encourage more people. If you have particular things you want us to cover as far as topics, we're open to those type of things. We have a few challenges that we haven't finished up from last year. In particular, I'm working on some things. I'll start working on those again. Life happens, so sometimes things get delayed. So it's a few things that is coming up in the future.
Yeah. All right. So I always echo these guys saying thank you. It's nice to have a platform, even if it reaches one person. I mean, to be honest with you, the knowledge is there for everybody. But even if it just reaches one person, I think that's enough too. So if we could help one person, then why not, right? It's a good mentality to have. On the side of a lot of what's coming up next is just keep or stay tuned, and honestly, like a lot of those topics we would like guidance. I mean, we'll find something, right? We'll talk about something, but if it's something about if it's something that you're passionate about, we'll definitely be able to kind of take it, and we'll take very good care with that, because it'll be something that not only we would like to learn more about, but it's something that you guys were very interested in. So please reach out with anything that you want to talk about. I mean, it could be space, it could be anything.
Yeah, definitely.
Yeah. So, or like what Nick was saying, if you don't understand anything, or if it's something, even if you say, hey, that's not right, just come talk to us about it. I mean, I'd like to learn about it a little bit more. Maybe we don't have the right perspective. It's totally fine. So, but we can't have those conversations if we don't push that point. So, once again, greatly appreciate everybody. Stay tuned. We've got a lot of stuff coming. And yeah, we'll see you in the next one.
I would like to add one more thing before we leave.
Go ahead.
When we are at the next event, if you guys would want to, do some networking, and maybe we grab a beverage, that's fine with us. You just reach out to us, and we'll be happy to meet you guys somewhere at the next event.
Sounds good.
Yeah, sounds good to me.
All right, y'all. Y'all have a good one, and we appreciate it.
Take care.
Bye.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.